All right, questions on the distinction between these three instructions? Okay. Let's move on to the last thing that I want to talk about today, which is perimeters. A perimeter is just the measure of the boundary that encloses a figure. And so if you take and you measure the total length or distance around the boundary of a figure, you have its perimeter. As far as the shapes that we have some general perimeter equations or relationships for. If we take the figure that's enclosed by one single line, and what is the perimeter of a circle called? Circumference. And the circumference is based on its radius, and the formula for circumference of a circle is pi times 2r, or 2 pi r. And because if you extend a radius across the other half of a circle, it becomes a diameter. We could also express this in terms of d pi. And in fact, this second equation for circumference is kind of how pi is defined. If you were to isolate this equation for pi, pi is equal to what? C over d. That is what pi is. Pi is a symbol that represents the circumference of a circle divided by the diameter of that same circle. And it's the same for every circle that you can draw. Okay, so here are your perimeter formulas for a circle. Now, what if I were to ask you if we take the figure enclosed by two lines? Is the perimeter, again, assuming that the radius of this semicircle is the same as that of the circle above, is the perimeter of this semicircle exactly half that of the circle of the same radius? And so think about what we have here. So if we took, on this circle, if we took a semicircle, a semicircle is half of the circumference plus what? Plus the diameter. So is the perimeter of a semicircle exactly half that of a circle of the same radius? No, it's half of it. So it is. So if we took 2 pi r and split that in half, we would be left with pi r. But not only do we have this curved portion of the circle circumference, we also have the what? The diameter, which in terms of r is 2r. So really what you're looking at is the perimeter of a semicircle is pi r plus 2 pi r. If we were to write this in terms of d, it's 1/2 of d pi. It's half of the circumference of that corresponding circle plus the diameter, so plus d. Okay. So again, you don't have to memorize these formulas for perimeter, but you should be able to originate them or derive them if it's necessary. Okay. Now, once we get to figures with 3 sides, the perimeter is simply the sum of the parts. So if we add up all sides, A, B, and C, for our triangle. And now we have some specific figures that have equations that relate to their perimeter. So if we had any parallelogram will have a perimeter that is, let's call this side x and this side y. Since opposite sides of a parallelogram are equal in measure, you have twice the sum of x and y, or you can think of that as separate twice x plus twice y. Right, if we go even more specific here, and we get into a parallelogram that has 4 equal sides, now if we say that the length of our side is s, the total perimeter would be 4 times that length s. And if we continue to get even more specific, we could write an equation for any regular polygon. So if we had a regular polygon, so all sides are equal, all angles are equal. And let's say even though I have a regular hexagon kind of diagrammed or sketched here, let's say just in general, n-gon. So there's n sides. If the length of each side of this regular polygon is s, then the total perimeter is the length of the side s times the number of sides, which would be n. So s times n is the actual perimeter of your regular polygon in this particular case. So again, we have some. Somebody willing to risk being wrong? Okay. Daniel, what'd you get? 49. Okay. 49. Jim, what'd you get? 63. Anybody else? Okay, let's go through and take a look at how this can be translated. Okay, you can directly get an equation from the information that's provided. Okay, you have 5/9 of, what does of translate into? Of means multiply. Okay, the perimeter, so here's our unknown, we'll call it P, of a semicircle is, what does is translate into? Equals, and then 35 is our number. So if we take this and just directly translate it into an equation, we have 5/9 of perimeter, so times P, is equals 35. Okay, here's the equation that we generate. We can then solve for P by multiplying by the reciprocal. We undo it by dividing both sides by 5, multiplying both sides by 9, cancels the coefficient, leaving just the P. 5 goes into 35, 7. 7 times 9 gives you 63. So your total perimeter winds up being 63 in that particular case. All right, let's say we go back to our sketch pad, and let's add 2 more points out here, and then let's completely enclose this figure. I wanted to find the total perimeter of this figure. Bless you. I want you to see if you can find the total perimeter of your figure, and it should have 5 sides. Here, you see that one of the options is perimeter, right? Okay, so what would be one possibility for finding the perimeter? So one, let's say you click each vertex and hit measure. Did that open up perimeter? No, because you're finding distances. Those are just the distances there. The perimeter refers to the physical boundary around. So if you highlight that boundary and click measure, oops. You still needed the vertices as well. So what you would need to do is highlight the lengths of, or the sides as well as the vertices. Still nothing, right? Did anybody get the total perimeter? All right, try this. Okay, highlight each of the vertices and fill in the middle. You remember how to do that? If you have the middle filled, can you now find the perimeter? Yeah. Okay, so here's the process that you would need to go through. And I'm going to give you one more way to do it here in just a second. So you can either fill the interior of your solid, or of your figure, and then measure the perimeter around that shaded region. Or, and the other possibility is, if you find the lengths of each segment. Okay, so we have AB. If we find the lengths of each of the other segments. Now notice, you can find those all at one with just one click, right? If you highlight each of the segments, go to measure and choose length. Okay, you now have all 5 of these lengths together as one, or in one group. Okay, and I want to show you how you can combine these. Okay, so rather than trying to do this now by yourself or use a calculator by yourself, if you go to Measure and click on Calculate, a little calculator pops up. Okay, and when you look at this calculator, not only can you add numbers and different functions, but if you click on a measurement, it takes the measure of that segment. So if we were to add this and do the same to each of these segments along here and hit OK, what do you notice about this compared to the perimeter? It's the same. And again, the nice thing with this is it's dynamic as you move things around. All of these adjust to where they need to be. Okay? And so my expectation is that you guys can find perimeters, you could find lengths, you can combine them into the